Okay, so that should be recording. Just wanted to start with just a few very brief comments before we get into the demo. Are there any comments on the meeting minutes from our last meeting? That was the demo from Move It To. If there's no comments, we'll go ahead and approve those and then post those up to our page. And also, just related to our last meeting with Move It To, were there any questions about follow-up? I know there were a few things that we wanted to continue on. Don't want to talk too much about it today, but I don't know if anybody had any questions or comments or wanted to have a breakout to do some more work with Move It. All right, I'm not hearing anything. I guess we'll move that off to chat if we have anything else. So with that, Marco, I'm going to hand it over to you. If you can introduce us to RMF and let's go ahead and get started. Thanks. And thanks a lot for presenting. I really appreciate it.
All right, thanks. Let me see if I can add my presentation here. How do I do this? All right, should be presenting now.
Yep, got it.
All right. Okay, so just for those of you that don't know me, my name is Marco, and I'm located in Singapore. I work for Open Robotics, and one of the main projects that we're working here is called the Robotics Middleware Framework, RMF for short. And mainly, I've been involved into the working on the releases, and I also lately started working, looking into the security part. That's why I started joining the working group, and that's why I'm here presenting this, so we can have probably some sort of discussion on the challenges that this system might present in terms of security. This presentation is it might go a bit into much detail, so I'll go a bit fast, maybe through some parts that might not be interesting from the security standpoint. But feel free to stop me at any point if you guys want me to explain something extra, or at the end if you want me to go over something else. Hopefully I can answer all the questions. So yeah, RMF is about multi-robot systems. So let's have a look a bit out of to the problem. So basically, just very fast over this, as robotics evolve, there's and deliveries are very common in many places. Then new applications are coming, new companies are coming, and facilities will have to adapt to all these robots being around. At this point, many robots will have to stay in the same place, and they will have to collaborate doing different types of flows. And these flows, each subtask of this flow might not be optimally to make them optimal. You might have to involve flows from different vendors. So multi-vendor integration has to be enabled, and that is one of the main problems that RMF tries to solve. There's many challenges with multi-vendors integration. And one of them is the lack of interoperability. So robots might not talk, these fleets might not talk the same language. There's infrastructure constraints because they need to share lifts and doors, and they also need to share routes around the place. It's hard to do realistic tests. So that is also something that becomes a problem because the places
Okay, so not just me then.
Yeah.
Yeah. Yeah.
Sorry, I think I lost my connection. Let me just. Is it? Let me select. All right, are you guys able to see?
Yep, good.
All right. So yeah, there's a lot of challenges, dynamic environments, people around, untrained personnel, and the main one that we're here to discuss is cybersecurity concerns. Here we'll only it's only pointed out the network data transmission, but at the end I'll point out a bit of the challenges that I've identified, and we can discuss about them. So what Rmf can do? One of the things that Rmf can do is task planning and allocation. So basically, you submit a task and it will allocate this task to the best bidder and will be executed. It manages the fleet traffic. So it will monitor traffic. It will try to avoid conflicts, but if there's conflicts, then it will try to solve them in an optimal way. And it also provides door and lift integration for this fleet to operate in the environment. And there's also interactions with Voxels. Voxels can be dispensers of certain items, or they can also be consumers, basically. So having a bit of a look on how it works. Basically, the robotics middleware framework is a collection of libraries and tools that facilitate the interoperability between these robots, the infrastructure, and other automation systems like dispensers or collectors, what we call voxels. And it has a certain level of intelligence to try to create this resource allocation in an optimal way by preventing conflicts on these shared resources. So if you have a look at the drawing on the right, you can see the core system, which are the dispatcher planner, which is the one dispatching the tasks, traffic monitor, and scheduling of this traffic. So that's the part that takes care of the task, allocation the tasks, traffic management, and solving any conflicts that might happen. And then we all around that, Rmf has different adapters, so it can connect to infrastructure managers for lifts, doors, gates, any other part of the infrastructure, Voxels, fleet managers, UI websites, of medical devices, and other parts of the infrastructure. One of the things that Rmf does is tries to simplify and standardize the messaging. So one of the systems that was created is the system of systems synthesizer. So this tries to solve the problem of different systems talking in different languages, so protocols, basically. So it's a plugin-based system where you can create your own plugins to translate between different protocols. One example of this would be the ROS2 translating into ROS1. So that's one of the things that you can do with SOS. And then we also provide the standardized messages. So there's a certain set of messages that can be used to interact with the RMF core. So task input adapters like UI portals will have task messages. Dispenser voxel adapters will have dispenser messages, lifts, and so on, right? Fleet adapters will also have fleet messages. So regarding the fleets, there's different levels of control that vendors are willing to give us. So we have identified four levels of control, which are mainly basically full control, where we get to control the waypoints of the robots when moving around. The traffic, what we call traffic light, which is like the robot can pause and can resume. We can pause and resume the robot. Read-only robots, which is basically when we can only know the location of the robot, and the ones that doesn't give us anything. So with the one that doesn't give us anything, there's nothing we can do about it. So Rmf will basically just try to treat them as moving obstacles, but it can can create some certain deadlocks. Read-only robots, we can try to navigate around them and plan around them, but more than one fleet of read-only robots can also create deadlocks in the system. And then we get traffic lights, and the best that we can use is the ones that we can control the waypoint, which is the ideal one, and the one that the API that will allow us to obtain the optimal solutions out of Rmf. So Rmf abstracts tasks for improved flexibility. So the way this is done is that the user has a certain interface, and this interface, through this interface, the user will submit a task. A dispatcher will will assign this task to a smart fleet adapter. So these fleet adapters basically bid for the task, and then the best one is selected and assigned the task. And then these fleet adapters will propose a plan through the schedule validator, and there's a unified schedule for all the robots and infrastructure that actually has to validate this this plan, and it also monitors the traffic. So as it's monitoring the traffic and it's accepting new plans coming, it can also identify conflicts. So once a conflict is identified, the smart fleet adapters of those fleets that are involved in the conflict will be notified. And those fleet adapters involved in that conflict will have to participate in a conflict resolution. We'll see how a conflict resolutions very fast. I don't want to waste too much time into that, but we'll see how a conflict resolution happens later. Rmf also introduces certain traffic conventions. So fleets follow a common traffic lane layout. This helps minimize the fleet interactions and simplifies adding new robots to the current traffic flow. Fleets follow traffic management commands, and fleets share the mechanical infrastructure like elevators and doors through high-level controllers that take care that nothing weird is happening with them. And there's also an implementation of emergencies. So if there's a fire alarm, if something happens, then robots can be stopped or moved away to safe locations.
Hey, Marco, I think we lost your slides somewhere in the last.
Oh, really? Sorry.
Yeah.
Sorry about that. Let me put it again.
There we go.
All right.
Got him. Thanks.
All right. So, resolving conflicts. So because it is the environment can change, and there's many aspects of the environment that can affect your robot task, like human traffic, unknown obstacles. Some lifts might be busy. Can be the intention can be changed. Tasks can be canceled. Alarms can happen. Then that's why Rmf has to resolve conflicts that can be unexpected. This is how traffic negotiation happens. So I'm not sure how interesting this is for us, but I'll just go very quickly through it. There are certain assumptions on this. So basically, is that each fleet does not know what the other fleet is capable of. Each fleet can communicate a plan that is feasible for itself, and each fleet can see the other's fleet's plans and try to plan around it. So in this case, we have three fleet adapters that are involved into this conflict, and then Rmf has to solve the conflict. The first thing that happens is that each fleet will propose their ideal proposal there, and after that, they will try to accommodate the other fleet's ideal proposal. So, for example, for Smart Fleet Adapter A, he will create a best attempt to accommodate B, and A will create a best attempt to accommodate C, and so on. All of them, they will do that. B will create a best attempt to accommodate A, and a best attempt to accommodate C. So once this is done, then they will use that information to create a best attempt to accommodate the other two tasks, two options, right? So the fleet adapter A will create a best attempt to accommodate the one that is created by B accommodating C, and the best attempt to accommodate the one created by C accommodating B, right? And so on. So this way we create a best attempt from everybody to accommodate the other tasks. Once this is done and we have this plans, there's a measure of the penalty that this these plans cost, and the lowest penalty is chosen. That is basically how it works. This penalty is basically a measurement that is currently being tested in different ways. So there's one that is the sum of the whole time that takes to complete these tasks, or there's also can be weighted with the importance of different tasks also. So now let's have a look at the toolbox. There's a bunch of tools that come with Rmf and that are very useful for deployment of this software. The traffic editor is one of the most important ones. This allows us to annotate flow plans and add walls, doors, lifts, and the traffic lanes. And it also allows us to place simulation models in this environments. Can also create statics or dynamic models like humans or others. And then these traffic lanes can be exported into vendor-specific fleet adapters. The building map tools package is the package that will convert an annotated map in traffic editor into a simulation environment like ignition or gazebo. So it can be used for simulation later. Needless to say that testing in simulation is very important, so I'll just go through this one faster. The assets that we've been using for our simulations are all available in Fuel. So if you go to Ignition Robotics Fuel, you can use them. And then we get to Rmf Core, which is the brain of Rmf. Rmf Core is the collection of libraries and utilities for assisting the vendors integrating with Rmf. So there's pure C++ libraries set for trajectory interpolation, path planning, schedule database management, and conflict detection and resolution. There's ROS2 wrappers for those libraries, and templates and examples of smart fleet adapters for fleet with various levels of control, lift doors adapters, and abstract task configurations. We also provide UI signal paths. So for streaming, we use the WebSocket with the ROS2 bridge to connect to the ROS2 core system. And for intermittent connection, there's an HTTP through REST server and then connecting to the core system. And then there's an operations dashboard. Currently, this dashboard it's in transition. I think
Yeah, we just lost you again. Sorry.
Yeah, I just saw that now for some reason. Let me just connect again. Yeah, so the dashboard, it's so the users can monitor the robot fleet, doors, lifts, the infrastructure, the schedule, and the trajectories that are happening in Rmf. And it has high-level commands to control the different assets in the system. Currently, there's a transition of the dashboard. It used to be RVs-based, and now it's transitioning into web. If you install the Rmf version that is packaged for Foxy, you will get the RVs version. But if you build from source, there's a bit of a weird it's a weird transition yet. So you will see different that you will still see the RMF panel there, but you will also get the dashboard on a web, and we'll see that once we get into the demo, which is right now. All right, so let me change the presentation into my desktop so I can show. And hopefully I can show you the window. All right. All right, let me see this. All right, you guys able to see my screen? Should be like a double screen.
Yep, got it.
All right, so I'm gonna launch the demos. Basically, this is all contained in Rmf demos. This is the repository that contains the demos that we have. There's 4 demos. There's a demo for the office. There's a demo for an airport. There's a demo for a clinic. And there's a demo for a hotel. And yeah, you can install them through packages. There's a book that is called the Multi-Robot book that also should be linked in these Rmf demos somewhere. There's instruction on how to install from source, and in the book there's instruction also on how to install from the binaries, the Debian packages. Yeah, so once everything is installed, you can just launch. There's a launch file, so you can basically launch the whole thing. This is the Office environment, which is the simplest version that we have. And you can see this is the Rmf panel. So in the RmF panel, you can see the lanes and you can see some of the waypoints. And you can also see the robots. So this version contains one fleet of robots with 2 robots. And basically you can ask the robots to do deliveries or perform either deliveries or loops between 2 waypoints. And the way to do that is to do it through the web. So if you're using the source version, I think it's 5,000. Yeah, it should be. Yeah, so there's the web panel, which allows you to submit the tasks. And as I said, it's a bit of a hybrid right now. So you get the lanes and the traffic monitoring is still in the RVS. If you install the version from ROS Foxy, you will see something like this. Still here, the Rmf panel, but it's just not in the configuration anymore. So you can also submit the tasks through the Rmf panel here. Yeah. So yeah, let's submit a task. So as I said, in this example, we can submit deliveries or we can submit loops. So we can submit a loop, starts as soon as possible. These are the evaluators for selecting evaluating the plans. So you can choose one of the 3s that we are provided here, but you can also just leave it by default. And let's say we want a robot to go from the pantry to hardware 2. And you can see the pantry is here. So it will be somewhere here. And the hardware part, let me see. Hardware 2, it's here, which is somewhere here, right? And then through the web, we see that we have 2 robots in one fleet. And we can also see the battery level being monitored here. So we can submit a request. And then the loop request has been submitted. And you can see the task has been submitted here. And it's pending. At a certain point, the system, one robot got assigned. You can see this little magnet robot is moving now. And you can see how the percentage is of the task is being performed. There's also a way to submit lists of tasks. So this is done by basically a JSON, and you can load it from the. So you can load a JSON file. I think it's from Rmf demos, demo task. Is it here? Resources. Yeah, here. So we have office tasks JSON, which is an example of a bunch of tasks in a JSON file. So you can see the JSON file here. Each task has different fields. And if you submit it, you will see the task list that's been submitted. And there's the task will appear on the task summary. Yeah, so as the tasks get allocated, you'll see the robot moving around, conflicts happening, and all that. Yeah, so that's for the demo. We can leave it running in the meantime. I can try showing later on maybe one of the other ones, but it will. I think it's going very slow. Let me just speed it up a bit. Can just change this. I can't see. It's too small. Now it's going a bit faster. Yeah, so while the tasks are happening, going a bit back to the security challenges, there's a few security challenges that we have identified. The main one is that we have to deal with third-party hardware and software. So that is a quite scary part. There's we need a certain way to recover from compromised parts of the system. So a way to revoke certificates is needed. We will also need tools for detecting intrusion in the system. So maybe we'll have to perform certain monitoring. We'll also have to have some sort of security management dashboard to maybe revoke permissions in from a systems integrators perspective. We also have to identify different levels of access for humans to the system. The network security is also a problem, mainly because part of the scheduler might be run at a certain point in the cloud. And also deployments are something that we have to be able to test and somehow certify that they have been secure enough. Yeah. So I think these are important points that we'll have to look into in terms of security. And yeah, thank you very much. If you guys have questions, I'm ready to take them.
So thanks a bunch. So I'll actually get it started if I can, and then we'll see what other questions folks have. But one quick question for you. I know you're somewhat new to the security working group. Do you have questions on how security works, on what you can do with ROS 2, and just how that would fit into the overall picture for you, or do you want to dig into that a little bit more?
I think because I also did there's a demo of this office that I created with the security enabled. So I think I went through I guess most of the parts. So I also even managed to make the ROS launch work with the no-deal part also. So I think I'm good right now. Yeah.
Okay, so Ruffin, do you have something? Go ahead.
Yeah. Thanks for speaking, Marco. Could you maybe expand on the human aspect component, on what you feel the security requirements are, particularly for the human interfacing?
So for human interfacing, I think that there's going to be we're going to have different levels of access. One of the key questions that we had is that we can have different access, different ROS nodes with different access levels to the system, and should we have one ROS node per user, or should we have one ROS node per role, right? Certainly, there will be like managers, system integrators, and for example, one guy with security management dashboard. So they will definitely need different types of access. I would say the majority will have basic access to the high-level task allocation dashboard, similar to the one that I
But you're, you're
that I
thinking,
just showed.
you're thinking an individual staff would have to have some kind of representation or identity in the ROS side of things, or wouldn't they more or less be abstracted away into like the back end fleet management UI, like any kind of normal web app where they have a login credentials and that's how they interface with the robots? You're thinking there's more diverse cases, or like mechanics or operators that are directly interfacing with the hardware?
Yeah, so certainly we would want pretty much everybody to access through web dashboards, I would say. Somehow this would be translated into some ROS security SROS permissions through the backend, as they will mostly will have to communicate to the ROS ROS2 environment. I would say there will have to be different levels of access, like from the, like for example in the hospital, which is where we're working more. Well, you get the nurses that will be just asking for deliveries, but then you will have certain levels of support that will have to be able to move certain robots or command specific robots, and then you might also need some guy that needs to monitor logs, and then maybe if robots are doing different weird things, revocate whatever permissions those robot has, or if a door is behaving in a weird way also. So I think that's and I think the most urgent part on the ROS side would be a way to remove permissions from one of the participants.
Yeah. So I agree that using sort of a traditional web-based portal probably the easiest way to manage access on a larger scale for consumer end use cases. I think when you get into the component where you do have to start reaching into the ROS system subsystem directly and negotiating the access control and permissions therein with more ephemeral like use cases and users, I think it's something I don't think we quite have a good story for, at least even as far as like security DS. You imagine like the hospital use case for like security DS and medical networks where you have like doctors that have portals that subscribe to patient data. Even then, I'm not sure it's really necessarily assumed that the doctor's identity is associated with the portal subscribing to the data directly. It's usually like at some broker access control model. There's like this, it's this sort of middleman broker that's delegating that, and that makes it so that the hardware level or the network level between the peer systems is relatively fixed and not so dynamic. But maybe there's a use case of having everything, even down to the low level, be flexible and tracking permissions.
Yeah, I agree. It seems that given the level of abstraction, it seems that like everything can be managed at the like where this manager, global manager, is running, and in the end, everything can be assumed through roles and web authentication, and then like the actual server that is commanding the robots will have access to send commands, but then it's just like a matter of like which role, like which people are logged in, which ones have access to that part of the system. But it seems that like the server itself will always have permission to send commands to robots. Or are you seeing multiple instances of the Rmf like framework running to manage such a system?
So the thing is that the dashboard, for example, will through the, let me see. Oh, I already removed it. So the dashboard will have connection to the authentication, to an authentication database, and based on that authentication, will use a different ROS permissions to access the ROS2 network. So that way, the dashboard, if the user, let's say a user is not allowed to submit any tasks, then when that user gets authenticated, the ROS2 parts would only allow the permissions to subscribe to that to the topics, right?
What's the conventional deployment networking model? Is like there's this database that's always online and always accessible, or are things like decoupled and peer-to-peer, and there's partitions and like
There's
everything's connected. Like you can imagine there's a redundancy where like if the power went out in the hospital, you'd still want means of telling robots what to do and where to go.
There's it's mostly decoupled, the whole thing. So right now, if you run this, the demos, they run pretty much everything ROS2 nodes, and then there's a connection to the dashboard. There's an authentication server that doesn't run on the demos, but this authentication server will connect to the database for users to be authenticated. And yeah, there's also, for the dashboard, there's several backends that interact with the dashboard for different things. So there's a backend to do the following the schedule, following the to check the nav graph and publish the nav graph on the dashboard and all that. So it's highly decoupled. Yeah.
Mark, I have a question for you on how you define the boundaries. I mean, when I think about SROS2, most of that's done with certificate hierarchy, and I don't know if you've played with that at all or thought about that, because it sounds like you have a robot and then a fleet of robots and then the whole task space, if you will, that's governed by the dashboard. Is that right? Is that how you kind of envision this whole, encryption, authentication, and revocation hierarchy working?
Yeah. So the idea is that so with SROS we are able to provide this encryption of all the network up to the backend's point, right? As I said, my main concern now is I would say my main concern are the third parties, because that is something that we don't control. and it's going to be very hard to control for any system integrator that is using Rmf. So I feel like there should be a way from the ROS side to provide this systems integrators to ideally it would be ideal to have like certain way to verify certain levels of security of these systems if there's a set of tests that can be run or something like that. And worst case scenario, there should be a way for them to revocate the permissions that these systems have if something happened. Because the problem is that these systems, they're not controlled by the systems integrators, or they might not be controlled by the systems integrators. And on top of that, the scope of the systems is pretty much everywhere. They're running around. So it's not only a network problem. It's a problem of like physical access to the systems. And to be honest, as we're building this system, we're currently asking vendors to provide us with APIs to be integrated into Rmf. And I have a feeling that these APIs are very new and not heavily tested. So I think that's one of the main concerns. And I'm not talking only about robots, it's also like lifts, doors, and all the infrastructure.
When you're dealing with these third parties, maybe be like a threat model, maybe to consider them as like semi or untrusted zones. On the higher level conceptual thing, we're kind of concerned with integrity and confidentiality and interfacing with these extremities. So like when you're consuming data from the third parties, you're concerned maybe about the integrity of the information, that it hasn't been modified, or like, you know, when the elevator shaft says it's open, you know, you want to you kind of have to take its word for it, because maybe, I don't know if you have it, if the third parties are using, you know, authenticated encryption or not, or where the data is coming from. And then the other thing is confidentiality. It's like when you delegate any kind of information from your ROS framework out to your third party, like patient room numbers or something like that, you want to be careful on what kind of information you're exposing. Do you have any idea of, like, at least in your conventional use case, on where those risks might come from in terms of what's susceptible in terms of confidentiality and integrity for interfacing with these third-party APIs?
You're asking what is the level of confidentiality that we might need in our use cases?
I'm saying, like, could you think of like what might be a factor in terms of, and how you might build like some kind of sanitizing or checks to ensure that you're only using information that you can trust, and you're only releasing information that you're willing to make public to these untrusted third-party APIs?
I would say that, yeah, that's a good question. Yeah, I would say I don't have an answer for that. That's one of the open questions that we would have to solve right now. Yeah, as we move forward, it's something that it's one of our main concerns right now. So yeah, there's
Hey, Mark, I have a question for you just on simulating this. And I think you've already covered this, but if we want to do some more work with just exploring different scenarios, including securing no DL and just continue working on stuff you've already worked on. Is that start with the simulator? Start with the GitHub repo is the best place to go, and is it fairly straightforward to add different robots into the simulators or extend those, or are they pretty solid, pretty like static?
No, I would say it's kind of straightforward. The source code you can just download. There's in the Rmf demos you get all the instructions just to build from source, and you can also, if you go to the book in the introduction part, you can just use the binaries if you want to check the system. But yeah, also it's quite straightforward to modify the environments, especially if you use the traffic editor that we provide. So or even create your own ones.
So I could start with the demo and then use the traffic editor to modify the demo and go from there.
Yeah,
cool.
Exactly.
Do you happen to have a link to the book? I'm looking at the site right now. I don't see
let me
where it's linked.
Pass you. So I'll post it here. This is the book.
Great, thanks.
And this is the link to Rmf demos. So that currently is the place where pretty much I would say like the instructions for installing and all that are. So I would say that the best way to start is to run these demos. I didn't run the clinic one because it's very heavy, but yeah, because I'm running on a laptop. But if you guys running on some sort of powerful workstation, it's very nice because you can see the different levels and you can see the lifts going up and down and all that.
So then this, when you run the simulator, you're simulating all the robots as well as the RMF core all on one machine, right?
Yeah, everything runs in the, ideally, that's another part. That's why I was talking about network security, because at some point, the part of the core, you might want to run it in the cloud. So that is a bit challenging also.
What kind of aspects are they looking to run in the cloud? Do you have an example?
So if
currently they have outdoors.
So if you look at the, let me see, where did I put my slides somewhere? If you remember the Rmf core part, the yellow part, which was the one with the task scheduler and all this, that it's probably gonna run most of the time in the cloud.
What slide are you looking at?
Let me. I can. Or you can look it up in the book also. I think. Yeah, I think in the introduction. The first drawing that you get in the introduction on what is RMF core system will definitely go into the cloud, but also smart fleet adapters and all these adapters can go into the cloud.
So particularly the program that's doing the scheduling and then weighting the schedules in comparison on the global optimum.
Yeah, well, technically, one of the tests that we're running is also running robots with internet connection and then just running everything in the cloud. So we connect through VPN to the robots and everything runs in the cloud.
So the only thing running on the robot hardware would be the sensors, drivers, and
Yeah.
the motor controller drivers. That'd be
But
relatively shells.
but at the same time, you also have sensitive deployments, like could be hospitals where you might want to run everything inside. You don't want to you don't want to get any of the data out of the hospital, right?
So
this-
they would run on premise with their own servers, or
Yeah. Yep.
even on the robot.
Yeah, so there'll be like there can be specific servers in the actual hospital or whatever infrastructure, so the data never leaves the place.
That's part of a compliance regulations like HERPA and stuff like that.
I'm not sure if it's part of the compliance regulation or if it's like just. But I'm sure there's places where there's scenarios where you can run RMF and the compliance will not allow you to get certain information out. Yeah. So you might have like information from like health information running around, right? Your patients, rooms of the patients, or this kind of information that is very sensitive.
Do any of the existing kind of robot deployments ever run on like air-gapped systems? They're entirely void of the internet or the rest of the facilities network.
So we don't
common use pattern.
So we don't have any real deployment yet. So we have a test deployment, which is with real robots, and that one is runs without access to the internet. But it's a minimal test deployment. It's not like an entire facility. But ideally, this is moving into real deployments very soon.
So we're running up against the end of our hour here. Mikkel, did you want to say something?
Well, I have a couple of questions, but you can also move them offline. One thing is that, like you mentioned several times, CRLs. Is that something you played with when you did your secure demo of RMF, or is it something that like because that's not something we expose explicitly in SROS2, but that's something that's supported by at least FastDDS and Connext. And so I just wanted to know if you tried to revoke certificates. And
No, I haven't tried, but I know FastRTPS is it's supporting that, right?
Yeah.
If I'm not, yeah. So, but yeah, I don't have any experience with that, but.
Okay, so that would be one of the areas you would like to explore in the near future for these demos.
Yeah, certainly.
And related to that, do you have, so you said you have a secure demo working. Could you provide also like the links to that as well?
It should be on the Office demo. It should be on the RMF demos. Let me check. Yeah, so at the end of the, I'll add the link here. But at the end of the Office demo, there's a link to the secure version. And sometimes because I created the whole, I added the policies and all. Yeah, I'll send it here. Yeah. Yeah, so that is run of the security demo, and the best way to run it is through Tmax. I created a Tmux script. So if you run it within Tmux, everything should be automated.
Awesome. Yeah, I think that like that would be the best thing for us to like if you want to like explore this is so your recommended way of testing and running this is to build from source and following the RMF demos instructions and whatever is on that README using the Tmux.
Yeah. So the first I think is the first line that you can see. There's a bash script that if you run in Tmux should be exporting all the environment variables and creating all the certificates that you need to run the Office demo.
Okay, cool.
So no, we were only scheduled to go for an hour, but I can leave the room open so as long as everybody keeps going. And Marco, if you're still good. And it looks like, Ramon, you have your hand raised. I guess you got a question?
Yeah, exactly. So, yeah, I wrote down a couple of questions. I don't know if you have time for this, Marco.
Yeah, sure. Go ahead.
Okay, cool. So what is like the short-term plan for RMF? Like what time do you think it will be deployed at customers? Like we are also a customer, or we are also in need of a fleet manager. Like is it too early, or what do you think?
You're saying that you guys are in need of a fleet manager?
Yep.
Oh, yeah. So we provide. We also provide the free fleet. So there's a fleet manager that is provided by Rmf. Let me find the. So we're already testing. As I said, we're already testing this in real environments. We're testing this in airport and hospitals. I would expect working to be started on real environments towards the end of the year, probably. But I'm not sure of because it depends on like projects and other third parties. So I can't guarantee. But yeah, feel free to have a look at the repos that we have and yeah, let us know if you have any questions.
And are there already standard adapters for like robots that run move base? Is it?
You mean like the specific adapter for certain robots?
Yeah, suppose I have just a ROS1 robot that runs move base. Is it easy to hook it up to RMF?
I'm not so sure on that part. Everything I know the guys who made that part, they made it to be easy, but I haven't played around with that. Yeah, there's specific instructions on the book for integration. So vendors can use the provided. There's specific steps, and there's in the integration part. You will see there's a free fleet section where you can have a look on how to use this free fleet, and this is directly integrated into RMF.
Okay, cool. I will. If you look at the examples you linked in the chat. And last question is more of a security question. Like, have you thought about fake robots connecting to fleet managers, preventing that, or the other way around, robots that are like connecting to a proxy that sniffs traffic from the robots? Those kind of security.
Well, the idea was to use the security features of DDS through the ROS layer, right? So if we do that, ideally the robot will need to steal a certificate to be able to.
So the robot knows it's connecting to the right server.
The robot. I would say the robot doesn't know if it's connecting to the right server, right? The robot just I mean, the robot knows the messages are coming from the right server. That is what it is, right? Yeah. However, as I said, some of these robots, someone might get physical access and steal the certificate. So that is I think that's the critical part in the whole system and the weakest right now.
Okay, well, thanks for answering my questions.
Yeah, thank you.
You have any more questions out there? So, Marco, will you be able to share your slides so I can post them with the meeting?
Yeah,
recording?
I will.
That'd be great. Thanks. Thanks. Yeah, so I really appreciate it. I have a feeling you'll probably get some follow-up questions as well. But yeah, it's great introduction to RMF. I did have one question. I don't know if let me see. Looks like we lost most of our folks. So just from Security Working Group, we'll follow up with this in the next meeting and figure out where we want to go between Move It and RMF and potentially some other things and demos and support some of these projects. I think it's some really neat opportunities here. So if nobody has anything else, all right, then thanks a bunch. Thanks again, Marco, for presenting, and I'll post the link to the video and some of the notes. You'll see that come through. All right.
Yep, thank you.
Thank you very much. Appreciate it.
Thank you, guys.
Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.
Thanks a lot.